So Ali is a professor of engineering in Jordan, and apparently very central for the entire university. He has found a few initiatives that were beneficial for the university, but kind of like many people here thought that being a professor was too easy, so he wanted to do more machine learning and more data science, and then he came to it. And he's going to do a live demo with food, so let's hope that it works. And then if it doesn't work, we can eat the food. Okay. So Ali.
My name is Ali Abul Hawa. My project is about estimating the calorie content in food dishes using transfer learning neural networks. So this is the first exciting image. To get you in the mood for
Thanks, please.
So what I wanted to do is to have an image using my mobile phone of any plate and estimate the calorie content in this image or this plate. Might sound easy, but it's not. My data set contains 100 classes of different food dishes. So why did I choose this project? I choose this neural networks because I think they are amazing. They do something really fascinating, and because they are challenging. I wanted to learn something that's really good to learn. Of course, there's still a lot of things to learn, and every day I discover new ways to implement different things using neural networks. Now, why the food project is because many people want to have a healthy lifestyle in their life, and one way to do that is to know how much calories they consume every day, for every meal they have. So when I described this project to some people, especially ladies, they were very excited about it, and they wanted this application now. They wanted to use it right away. For men, it was interesting, but not me. So my presentation doesn't have a lot of slides, so mainly this food images. This can be used for many different applications, like it can be a standalone application just for estimating the calorie content of foods, or it can be used for, I discussed this with insurance companies, probably to see if you have a healthy lifestyle of eating, then we can reduce the premiums. If not, we can increase the premiums. But anyway, I want to talk about my data set. It contains about 15,000 images. It's not a lot, considering that there are 100 classes and roughly 150 images per class. For neural networks, we usually need a lot more images per class to have a good result. But with transfer learning, that's possible. They are mostly of Asian or Japanese food. Some dishes are like chips, burgers, pizza, spaghetti, but mainly Japanese food. And the size of the images was not uniform. They varied from 80 by 140 pixels up to 800 by 800 pixels. So that was an interesting thing to see how the neural network performs in this large variation. I didn't like to tweak my data to match to give me a good result. I used the data as it is. There was a lot of noise, but I thought let me just use it. in this data set there was a text file for every image in every class to crop the object within that image that's being labeled. So I went through all these files using a simple Python code, and then I used this new crop data to train the neural network. One of the other problems in this data set is that it's about food, which looks very similar. Some dishes, I don't know. I've recently know that there is something called ramen noodle, and it looks like this. But if you give me any of these images, I would say they are the same. But with this neural network, it can have some distinction with a good accuracy rate. So, what's transfer learning? Let's just quickly describe transfer learning and how I used it in my model. So, the main idea is to use a pre-trained neural network that has been trained on a very huge data set. There are many of these neural networks available. The VGG16, it's a group.1, the ImageNet competition 2014. It's from Oxford University. They used a huge machine composed of 4 of the top GPUs, graphics processing units. Each one costs about $1,500, so a total of $6,000 only for the GPUs. Why do we usually use GPUs? Because they have multi-cores. Like this, I think this Titan Black contains probably 3,000 cores compared to CPUs, which are 4 cores. So they can run this training very quickly. And using this machine, using the 1.2 million images as a data set, they finished their training within 3 weeks. If I used my computer to do this work, it would have taken me 30 weeks. Now, my computer is not basic, it's gaming laptop. Contains a graphics card similar to the G2 2X large instance on the Amazon AWS. I compared the two and they almost the same speed. So this neural network has been trained for many hours, many weeks on this data set, and it became very powerful in extracting features. They use it to classify images, but in the middle part, it's a very powerful feature extraction device. And the first few layers, they extract low-level features like lines, curves, blobs. And then as you go forward, they extract more visually known features. Like here, for example, for this car, you can see probably some wheel at the higher level features. And the last layer is the output classification layer. And for this example, they have 1,000 classes, and they are sorted from top, the highest probability, down to the lowest probability. So usually, machine vision classification problems, we refer to top 1 accuracy, the highest probability of the class with the highest probability, and also the top 5 highest classes. And I will refer to my model and how it performs. So the way to implement transfer learning is to cut the last output layer. So previously it was this layer had a classification of 1,000 images. It was used for cars, animals, chairs, furniture, different things. And I used this middle part as a feature extraction device, and I attached to it my own custom output classification layer of layers. So I only train, I give the images, pass them through this VGG16 minus their output layer, and then I train this layer of layers. Now, with this implementation, I got an accuracy of about 52%. Now, this might sound bad. 52 is like flipping a coin, and it's 52. But now you have to consider how many classes there are. There are 100 classes, so the random probability of picking one is 1%. So that's 52% better than random selection. Now, what we can further do, or what I did, is to train the layer just before this layer. So I did this training, and this takes this part, only adding one layer from the VG network, it takes a lot of time. But compared to 30 weeks, that's not much. It took about 30 hours to do this training on my computer. So I trained the higher level features of the VGG to obtain higher accuracy. So I got 70% for the top one related class. And for the top 5 accuracy, it was about 92%, which is considered relatively very good. Last night I did some extra modification on my dataset, and I got like more reliable numbers, slightly less but more accurate, less by 2%. I could have done more, but I started at 12 at night. Let it run on Amazon AWS on the P, the higher instance, and it finished at 8, so it was good. But I didn't have time to change the numbers of the slides. So, why do we use transfer learning? Of course, it's mainly to save time. Nobody nowadays uses neural networks and trains them from scratch. They use something that's already been trained, that's been very good in extracting some kind of features. It can be used even for audio sounds. Maybe a slightly different network, but the same neighborhood is the same. And the good thing is that with transfer learning, we can have even a very small data set, and it will do a good job in doing what we want it to do. However, if you have a really very small data set, like the one I had, for one class I had 40 images of testing and 70 images for training. I had to do a lot of aggressive image augmentation, which means the same image, I had to rotate it, zoom in, zoom out, do many image manipulation so that it looks like it's a new, different image, but it's actually the same image. And this helps to reduce overfitting the model that we are training. So this is the final slide. Yeah, this is what I tried. It's an image for sushi, and it gives us the same image with the label, the name of the food, and the calorie. Of course, the calorie here is not accurate, it's per server. I could do more. I mean, this can be the next phase for this project to find the size and the number of pieces, but as I had to limit my work to per serving, otherwise I would need more time to do that. But it is doable.
Okay, so now we're going to do a live demo with actual food.
Yeah, I just need 2 minutes to set up the demo.
So they just, I actually don't know which categories he has, but it's probably not curry, chicken, whatever we have there. It's so just put 1/3 of veggies, 1/3 of meat, and 1/3 of rice. Let's see what it says.
Sushi.
I did a quick implementation using Dropbox and a folder shared between Dropbox and my phone and my laptop. So I'll just run the model.
So you have to imagine that in the future there will be an app that you can install and then you can take a picture of your food.
I thought of making an app, but I don't want to get confused. So I will take a photo. Let's see how it works.
How much calories is that?
That's exactly.
Is it? Let me zoom in.
It's actually kind of weird ingredients. It's this tiny bit of corn that you never see often, and the other veggies are this white gold thing that it's also looks kind of like a chicken leg. It's actually veggie.
So now it's just received into my computer, and it's been classified. Now it should return the. I don't want to override the image. I need 2 images, one for the top one prediction, and it's beef curry.
Oh!
Nice.
I have a dream. You should share.
And this one,
I have to that's all, right?
so it contains 120 calories.
That's nice, that's nice.
Now the top 5 predictions, in case this wasn't like the correct, you can refer to the next. And it's the second one, although you can't see it, I have to zoom in. It's 2, then beef bowl, seasoned beef with potatoes, fried rice. So it's relatively, I think it's good. It needs some work, but for now, I mean, within 3 weeks of work.
Yeah, I'm training on sushi.
And the lighting is not too good there.
Sorry?
The lighting is...
Yeah, the lighting
the
plays a role, but it has been, in the augmentation part, it has added many effects. It didn't include the effective lighting, but it's a good idea to add the effective lighting.
Okay, you go demo effect, and you go live with the thing, and it actually works, it never happens.
Sure.
Thank you for listening, and hope you enjoy the meals. If you have any question, please answer.
The second image, does it tell you the components of the plate, or is it just all of the
It's
food?
a dish. I didn't go into the ingredients of the plate. Just as a dish, what's the amount of calories per serving?
So Michael, you were a former Olympic athlete, you may be able to count calories like a lady, and you say, can you say this is 520?
The diet figure sounds alright to me. Yeah.
Okay, cool.
I mean, how did you match that? I mean, because it's hard to get the volume,
Yeah, this is it's not easy, especially from a two-dimensional image.
Yeah.
But there is some. I found some research master thesis only just to estimate the size of the image. It is done.
Yeah.
But I think it depends on how high is your phone from the ground and the angles. But it is possible to do it. Or there are some data sets with a reference. Like
For rice corn, how big is it?
Like you can have €1 beside this, you know the size of the euro, so you can estimate the size of the
But if you're sure about one piece of the food, and that size could have as well, like the rice corn or any food that you're sure about that has a size reference.
Yeah.
You follow some pre-processing techniques to basically reduce some of the noise before injecting that into the model?
For the images?
Yeah.
I didn't try to. I wanted to see how it creates a noise, like in a real life problem. The only thing I did is to have one object in the image when I trained it, and so I only cropped the objects because there were some images with many objects and different things, and this is the only image processing, pre-processing that I did on the images.
I'm just wondering, because the calories, if you take Coca-Cola, let's say, and you just put that on a rice plate, and it's dark sauce on rice, photo-wise, but it totally depends on what type of sauce it is to make the calorie count. But then you can't be sure of all the ingredients of a mix-up Vietnamese dish that we see here. I mean, some of it is biomass, and it doesn't matter because it's sort of within range, but something like sugar then totally destroys. But would you go item by item that you recognize and make a guess on size and calorie specifics, or?
Well, let me just explain how a little bit about machine learning in general. What if an expert cannot say what's in this plate from the same source of data, then the machine cannot. The best human expert is our reference point. Of course, the speed is for the computer is much faster, and there is some pre-processing, like if there is an image with blur, some pre-processing can remove this blur, which can result in better accuracy from the model than a human expert. But if there is Coke instead of soy sauce, I can recognize it, the computer can. I can't, the computer can't. And I hope this answers.
He's supposed to be from the SR, he's asking the nasty questions.
So if there are no more questions, we can enjoy our lunch.